All right. So the workflow I'm going to present today is part of a study that was conducted at the University of Geneva when I was a student, and it's meant to explore the concept of essential variables in the context of mineral extraction. And in particular, we proposed a series of different possible candidates for essential variables for the extractive field, and developed one that is meant to target the SDG 15, so life on land, considering the impact mineral extraction have on forest area. We developed a workflow that is meant to estimate the surface of forest that is lost as a consequence of mineral exploitation. So as I say, the target that is the SDG target that is targeted is the 15, the life on land, and even if it doesn't exist on the UN repository, an indicator that is exactly like this, there is one that has some similarities, that is the 15.3.1, and for an estimation of the land that is degraded over the total land area. So the workflow aims to operationalize the calculation of a variable that can monitor the influence of the mine installation on the forest area, and the area that we targeted was the Democratic Republic of Congo. And the workflow is implemented based on geospatial data on the forest cover and the surface occupied by the mining site expressed as mining concession. And so we started from the assumptions that mining sites and forests cannot coexist. So we considered mining concessions as potential extractive site, and implied that for every mining concession, there's going to be removal of vegetation in order to facilitate the construction of mining facilities. So the input that we used are a set of raster containing data on the tree cover, expressed as a value that goes between 0 and 100, and they're expressed as a percentage of forest cover for that pixel. And then we used shapefiles, so polygons of mining concessions. And on this image, on the left image, is a mosaic of all the TIFF files that we use to cover the region of interest. And the little small polygons are the pink polygons are the mining concessions. And the output file is of the workflow is derived from a spatial overlap between these two data sets, so the raster and the polygons. And on the right image, there is I'm showing the results of this intersection of this. So it's the surface of the forest that is overlapping the mining concessions. So as first thing, we tested the workflow on ArcMap in order to have a visual support and to easily access the geospatial data. And later we converted it into a script a bash script that was conceived to automate the process of data treatment, and we used open source libraries such as GDAL. So this is the script that we developed, and it consists of a central part. So in the central part, we extracted the extent and the resolution of the forest cover raster, and we used it to create. We used it to transform the polygons of the mining concessions into a binary raster containing the information for the mining concessions. And then we combined the two raster data sets in a sort of extract by mass tool that is available on ArcMap, so that we could create a new raster containing the mining concessions overlapping the forest area. And finally, we calculated the extent of the surface occupied by the surface that we extracted from the previous command, and obtained the surface of forest that is supposed to be lost as a consequence of the mining the mining facilities, the installation of the mining facilities. So as I say, we had different raster in order to recreate the whole region of interest. So the first output is a file that contain only is a text file that contains only the information for the single tiles, and then we inserted a loop, a for loop in the script in order to redo the same central part of the script for the tiles, and then obtain a second output file that contains the total of the surface that is lost. And so we used a GDAL library because it already contained all the libraries and all the things that we needed to run the model. And after we tested this script on local, and once it was working fine, we transferred it into we went through the GitHub process and the Docker in order to transport the model on the VLab and try to run it on the VLab. So this one is the actual model that can be found on VLab. So we have the inputs. They are the vector for the mining concessions, and then for our case we use 5 raster to cover the whole region of interest. And then we have the 2 outputs. So the first output file that is the result for the single tiles, and then a second output file that contains the sum of all of the single raster. So this is the model, and how we implemented it, and to port it on VLab. And concerning the difficulties that we found, they're more or less the same that Marta found herself. So we were able to run the model on local, and then personally as a beginner in this area, I found difficult the whole process of transferring the data and the script on GitHub and then test it on Docker. And so even if it was clearly explained on the instruction that were provided for porting a model on VLab, I still found some difficulties. And also the other issue I found was the one concerning the use of Docker on a Windows machine, because every time that I open my script on my computer, then the script wasn't working any longer on Docker. So every time I needed to figure out why it was giving me errors and why the model was working on local, but it was not working on Docker. And then when we finally managed to transport the whole thing on VLab, there were still issues concerning the why the model is working on Docker, but now it's not working on VLab, and the fact that when there was an error, the type of error, the origin of the error was not stated by VLab, so it was complicated to understand at what level we made a mistake. And yeah, and also we had the same problem of having an empty file as an output. So the model went through till the end, but then we had this empty file with no content in it, and still the problem was to understand what went wrong and what was the reason of that. So this is it for my side. And if you have any questions, let me know. Thank you.
Thank you very much, Mariapaola, for this very complete presentation. I don't know, Mattia, do you want to react to some of these points?
Yeah, well, more or less, it's what also we were discussing before. In general, yes, in terms of the error that is not clear, as I said, the error is something, that we should improve, the error feedback to the modeler. In general, my suggestion is to look at the execution log of the model. When you do the porting and run an experiment, on that porting you have both the, let's say, status of execution, which is what Marta was showing, but you also have the logs of your model, so the logging that you provide in your code. That is a very useful output that you can use to, let's say, see what went wrong during the execution. It is actually the most useful thing when everyone codes any application. Logging is there for this reason, and you have the possibility to view the execution log on during the execution of your run. So this is a suggestion I would like to give to all the ones who are doing the porting. And again, maybe we should, I think it is already in the documentation, what we should give it more visibility, because it is a clear feedback from the tests that were presented today. Yes, someone was saying something?
I would like to add something.
Yes, please.
I would like to just let you know that during the last days, I just tried yesterday, the execution log was not working. I couldn't see anything printed from the execution of the code.
Okay, we look into that.
Great, thanks.
Yeah.